Welcome to Weidmüller and your digital fair experience. SPS 360-degree, personal, digital, live. I am Michael Herfen from the Weidmüller Academy, and I will guide you to the tour of Enjoy Cabinet Building of the Future. You will learn about the new Klippon Connect TTB Range, which is used for instrument transformer wiring. And who could present this any better than Davide?
Thank you very much, Michael. A warm welcome also from my side. My name is Davide Montaldo. I am Strategic Product Manager here at Weidmüller Klippon Connect. And today I'm going to enthuse you with this new product launch that we have ready for this trade fair, which is called, as Michael said, the new TTB range, part of a Klippon Connect for instrument transformer wiring. Now, normally when a presentation like this starts, we tend to give only the first image as sort of a welcome image, but in this particular case, this has something more into it. Why is this the case? Because, as said before, this is part of Klippon Connect, and if you're familiar with Klippon Connect, this means a lot of things. We have pillars, which are the foundation elements of this proposal of DIN rail mounted terminal blocks. We have, of course, focused ourselves in developing the right solutions for the specific application areas within the cabinet. And then this argumentation brings us, of course, to where these terminal blocks are actually used. We see here a complete energy system. In fact, this is where these terminal blocks are used because energy system is very big and is very complex. And when I say complexity, I mean also the type of devices that are used in an energy system where normally there is the need to exchange energy and to protect the line transmitting the energy from certain events. For these both cases, we use, or the customers use, devices which are called instrument transformers. They are vital components, they are vital devices, but they are very delicate in the sense that they have to be also handled very, very carefully. And having this in clear focus, we have developed this new range of bespoke terminal blocks that are called the Instrument Transformer Terminal Blocks, or TTB range.
Thank you, Davide, for giving us this framework. Coming from the big substation, I think it's now time to take a look at the real terminals.
Thank you very much, Michael. And here we are. We see a complete example here of what is a system looking like. So not only the terminal block themselves, but we see like a standard configuration that we could normally find in a metering cabinet. We see from right to left the part of the circuit which is devoted for the current transformer side. So you see that the standard arrangement is requiring 2 terminal blocks for each phase with all the accessories. So you have the test sockets, for instance, and other components that I will show later. And going towards the end of this small example, you see, of course, the part of the terminal assembly which is devoted for the voltage circuit.
Thank you, Davide, for the real hardware. Now I think we can go deeper and closer to the details, to the features with their advantages leading to big benefits for the users, for our customers.
Thank you very much, Michael, and I'm very, very pleased to do so because now is really the core part of this presentation. I said before that this is an integral part of Klippon Connect. Now, what does this mean? Of course, developing bespoke products for bespoke problems the customer have. That is one of the important pillars of Klippon Connect. The other one is understanding that, and this is also the key theme for this trade fair, what are the productivity drivers for our customers in assembling and delivering the cabinets to the end user. Okay, so we understand this very, very clearly, and of course, for this, going through the various advantages that this range is able to provide, we follow the circular approach of Klippon Connect. So we start considering what happens at the planning stage. Now, the planning stage is, of course, very much streamlined thanks to the Weidmüller configurator, the WMC. A very powerful tool that we have developed along with the customers, of course, to streamline the process of planning the cabinet, and nothing fits more into purpose of doing so when we are in the presence of instrument transformers, because they, as I said before, are very delicate, are very tricky, so we have to understand and look into this process more and more like a complete system. The software allows the customer to assemble the rail bespoke in exactly the way the customer wants it to be, with all the accessories, understanding what is really needed for each part of the circuit, and guiding the customer through choosing the right accessory for the right device to be connected. So no likelihood whatsoever to make any kind of mistake, which I repeat once again, are very, very dangerous. The data provision is absolutely complete in the right format. Not only the amount of data, but also the format of that data is very important. And very importantly, the outcome. So the product of configuring a rail leads the customer to the possibility of ordering with one part number the complete rail already assembled with only one click of the mouse.
David, why don't we take a look how this really works in the software? Because it's so easy and so intuitive, we shall share that.
Absolutely, absolutely, Michael. So here we see an example taken from a real case example. So what happens if we want to assemble a rail which has the usual configuration, 3 phases, both current circuits and also voltage circuits? We are very, very streamlined in operation in assembling this rail with all the accessories without any possibility of making mistakes. And you see that the product on the right-hand side is the configured rail. So as I said, no problems whatsoever of making mistakes, and also having this phase, which is also from a planning perspective very, very expensive. Other features that are also present in the planning phase, of course, the possibility of giving a lot of functionality in a confined space. Therefore, this is really a live part of the planning process of a cabinet, and usually the user is confronted immediately with a problem, and that is space. How much space are we having in that portion of the cabinet to install the terminal blocks forming the rail assembly, which are devoted to connect instrument transformer wiring? And in this perspective, the most important dimension is, of course, the length of the terminal. We will see later that all the functionalities are kept within this threshold, which we give in 100 millimeters, and that is absolutely outstanding from the functionality perspective that is embedded in this dimension. Another important fact is that all the accessories that are forming the system are very much streamlined, and therefore there is no possibility on the one hand to making mistakes, and therefore also the likelihood of picking the wrong accessory with the wrong terminal block is diminished almost to zero. This is thanks to the Weidmüller configurator on the one hand, but it's also thanks to the design of the complete system. Normally, these cabinets require also some sort of reference point or start point to be made. This is possible with the new TTB range thanks to a Contour IP terminal, which has the provision to create very quickly and to wire this very quickly by a Contour IP terminal block exactly on the level of the DIN rail, and using a standard cross connection. Going through the cabinet building process and giving this advantage in all stages, we encounter, of course, the next task, which is, of course, more on the installation side of things. How do I translate that circuit into my rail assembly? And normally I am required, especially if I'm tackling the needs of a protection relay cabinet, one of the 2 big application areas for these products, this flexibility is normally carried out by cross connections. The design of the TTB range is done in such a way that we have allocated one cross connection channel, both upstream, the disconnect point, and also downstream. And this has no conflict whatsoever with other accessories, which on the other hand perform a very important role, such as, for instance, the test sockets, and even more so, the short circuit bridges. Having one cross connection upstream means that I can easily, as I said before, realize the start point, the earthing point of that start point, but downstream allows me to get that level of customization to the rail assembly, which I'm actually needed when I need, for instance, to wire up a protection relay cabinet. We understand that retrofit in cabinets is an important problem to solve. Again, we are an installation, and we have tackled this issue from a very simple point of view. What happens if the owner of the assets wants to prolong the life cycle of its own cabinet and is not requesting or is not pleased to stripping off even the DIN rails? We avoid this because we equip the new terminal blocks with a combi foot. That allows the customer to change towards the TTB range because of the functionality, but leaving everything else inside, including the mounting rails. This is a big practical advantage that we are giving to our customers. The lever mechanism. So the disconnect, because this is a range of disconnect terminal blocks, is designed according to what we call a unique lever mechanism. Now, I will focus on the lever mechanism firstly. The lever mechanism has some rationales behind it. Why did we choose the lever mechanism? Reason number one, that allows the customer always to enjoy a contact which is provided almost in digital status. It's either completely closed or it's completely open. And therefore, especially if we are considering connecting the secondary wiring of a current transformer, this means safety. Secondly, when I'm more looking into the maintenance operation of this cabinet, I'm looking into the technicians which are performing the maintenance operations in the field, and they want to know, even if the lighting conditions are not optimal, if that contact is closed or open, and this is very much eased by the design which is embedded in the lever mechanism. Thirdly, goes towards the other theme, which is flexibility. I said before, when I discussed about the cross connection, multiple actuation of disconnect points is more and more requested because circuits are getting more and more complex. And this is really possible with the lever mechanism, and with other systems like a slide link, this is not possible. Another advantage is given by the fact that the lever mechanism avoids, as a consequence to the first point, the accidental unloosening of that slide link, which causes so many problems. I named just two. The best case scenario is that the contact get loosened, not to the point of opening up that contact, but enough to generate severe heating problems. And that is damage, of course, to the terminal blocks, therefore to the asset, the cabinet. Second, which is even more, which is worse, of course, the complete opening up of that contact, which leads to the explosion of the CT, and you can understand what this actually means. But now we come to the unique part of this sentence, why this lever mechanism is unique. Because we are embedding within this same system a make before break contact for CT wiring. Okay? So I will really explain why we have chosen these words. Literally, make before break means I make the short circuit on the secondary wiring of my current transformer before I operate the complete disconnect operation. And you can see this in a number of examples taken from a simulation of a circuit, but I can say that we have also an animated sequence afterwards. Going through the advantages, so how we make the life easier also to the people who actually devoted to perform the operation parts. Okay, so normally in these kind of cabinets, there are two operations which are part of the daily work. One is, of course, replacing the device which is in the field, and we can see an animation afterwards. But even more frequent is, before we get to that point, understanding the status of that device. And this is normally done in current circuit by performing the so-called calibration or comparative measurement. Without going into much detail at this point, I can say that this feature is very difficult to accommodate with the make before break. It's really a trade-off. You either can design a solution enabling the customer to have complete safety, but not when it comes to performing a comparative measurement, for the simple reason that we must allow a serious connection between a calibrated instrument and the field instrument. This is possible, however, with the design we have chosen for this terminal block. And for this reason, this solution is patented by Weidmüller. All the accessories that form an integral part in delivering that required level of safety are kept captive within the arrangement. This is a typical case. We don't no longer speak about terminal block alone. We must understand that this is a complete system which altogether brings safety, the required safety. And therefore, the accessory plays a vital role in this. We understand this, and we have designed the system so that all the critical safety accessories are kept captive in the arrangement of the rail assembly. The technicians performing the operations in the field need to identify which circuit is connected to which terminal block, which instrument is connected to each terminal block. And this is why the marking comes into. Normally the marking is considered as a feature for the installation, but in the perspective given by the TTB range here, it comes in the operation because the technician needs to detect from all angles, from all visibility conditions, what device is connected to what terminal, to which terminal. Also, very importantly, the operation implies, as I said before, testing. Now, sometimes it's very difficult to insert a very thick testing probe, which is associated to a very complex and expensive piece of equipment, to a terminal block which has only an 8.1 millimeter pitch, like in our case. We have solved this issue because we have designed the test sockets in such a way that we allow, even with very thick test probes, the adjoining insertion of these probes within the pre-assembled rail assembly. The switch lock. We need to do these kind of operations. In our case, we provide the user with the possibility to detect that the subsequent opening up of this circuit is something that should be reserved only for authorized personnel. Because we intend that this operation is already safe, and the reason is because we have an integral make before break system. However, we understand the importance of giving this level of warning to the users, and that's why we have flagged this accessory in red. We can provide the possibility to blocking the position of the lever either in an open position, in a closed position, or even in an open position. We are providing also the system with the possibility to have a cover hood, which means that, especially in metering, we have a pre-configured number of terminal blocks forming the rail assembly, and we can allow this portion of the cabinet to be sealed. Each support has 2 sealing options, which together form in the system 4 independent sealing options. But for mechanical stability, this system is so stable that normally only 2 positions are required. The cover profile goes right to the very base of the cabinet, which means that there is no possibility whatsoever that any mishandling can take place from the sides of the terminal, therefore having the possibility to dislodge the cables from the clamping units of the terminal blocks. Utility companies normally require not only the pre-configured rail assembly, but they want to have a special color. Yes, that is the case because, again, to ease the life of their maintenance teams, they have conventions, so to speak, that each phase is colored with one color. We provide this by supplying terminal blocks in different colors, yes, but the novelty here comes that even more so, we do the same in providing a various, like a rainbow possibility of different colors to identify the circuits on the level of test sockets and also on the level of lever links. Last but not least, the IC-CB scheme. Another perhaps surprise in this presentation. Normally, the CB scheme is deemed to be a hygiene factor. Well, it is in fact. But we are placing the CB scheme certification at the very end and related to operations, because we have certified the new WTTB6 range according not only to the reference standard, which is the IEC 60947-7-1, but to its normative annex, which is Annex D. And that means a lot of things. In a nutshell, it means that we guarantee the full safety and full functionality of this system throughout the entire life cycle of the complete cabinet, which can be up to 25 years. And this is a unique feature also that Weidmüller is providing to its own customers.
David, you already stepped forward. I think we have presented a lot of the pioneering features which lead to obvious benefits. But now I think I want to better understand the wiring and the switching sequence. And I think you have prepared this very nicely.
Well, I hope so. I hope so indeed. So I have stepped a little bit forward, but now we will see what actually happens when we look into the heart of the system. So that famous unique lever mechanism, what really does it mean in practical terms? So please look on what is happening on the screen. Look at what is happening to the lever and to the components forming the mechanism, and also what is happening simultaneously to the circuit, which is representing a standard arrangement of two terminal blocks used for secondary wiring of a CT. We are now at stage 0, so the system is working as normal. That contact is closed. We are having a current flow from left to right, so from the secondary wiring of a CT towards the instrument which is located in the field. Now we need to do something. We need, for instance, to replace the device which is located in the field, and therefore we must disconnect the circuit. By doing so, from right to left, we reach a middle position, and this is exactly, and you see this is replicated also in the circuit, where we are beginning to deliver the short circuit which is necessary to avoid that open contact on a secondary wiring of a connected TC in order to avoid an explosion taking place. This is the short circuit phase whilst maintaining the circuit closed. We complete the cycle, we open up completely the lever, and now we are on the one hand maintaining that short circuit, but we have now reached a stage in the mechanism that contact is completely open, and therefore we can do whatever is requested to be done, for instance, replacing a device, but in full safety. So, having understood this, now we look at two very common operations that normally take place in our cabinets. And we start from the easiest one to understand, which is, of course, the need to replace something in the field, for instance, replacing an ammeter. Again, I invite you to look on the right-hand side of this slide and also to the left. First of all, we need to equip the terminal blocks. We will be using 2 terminal blocks for each phase. So first of all, we need to equip the system with a short circuit bridge. Exactly, you see it here. The accessory can be visible above the terminal blocks and also colored in orange in our electrical diagram. We now insert the accessory in a captive mode in the prearranged terminal blocks. So now this accessory cannot fall out. This level of safety is from now on guaranteed. This is replicated by the fact that the circuit portion has now changed color from orange to black. Now we do the same with the mechanical connection between the 2 levers, the so-called lever link. We insert it, again in a captive mode, and again you have seen the color changing on the left-hand side from orange to black. At this point, the system is safe. Therefore, we can connect both the upstream part, which is the secondary wiring of a CT, to the field device, which is, in our case, for simplification, an ammeter. We now move the lever in one step from right to left. And you have seen before, this guarantees us a complete safe arrangement, safe operation, and now we are able, in full safety, to replace that ammeter or that device with a completely new one. After having done this, we can restore the operation in original safety condition and status. But possibly an even more common operation that takes place before we get to the point of deciding to change in something in the cabinet is understanding, assessing if that instrument is working properly or not. This is possible, and this, by the way, is the unique solution also that Weidmüller provides. Again, I invite you to look on what is happening to the slide from right to left. So we have again to arrange the system accordingly. So we equip the terminal blocks with the short circuit bridge. Now it's orange. Now it's part of the configuration in captive mode, integral safety guaranteed. We do the same with the lever link. We insert it. Now that is also part of the system. And for this example, we use also the test sockets. And in this perspective, also the test sockets are kept captive. We have now reached the same status as we reached in the previous example. The system is now safe. It's ready to perform the operation which is asked to do. And at this stage, we can connect, of course, the field instrument, the ammeter, and also the upstream part, which is the secondary wiring of the CT. This solution that you have seen here is covered by patent. Weidmüller is unique in providing this solution to its customers. After having equipped the system, we now see what is the actual operation. We have, of course, the provision of the calibrated instrument, normally a very valuable piece of instrumentation, which is connected in parallel to the terminal blocks, and you see this replicated in orange, but in series eventually to the circuit. Now, the lever link is slightly lifted up so that the mechanical bond or linkage between the two adjoining levers is released. At this stage, I can selectively open up one of the two levers, the one which will be allowing the current to flow through in series, so that this operation takes place. And you see in orange, you have the stream of current flowing for one pole of the secondary wiring of the CT through terminal number 1, which is kept closed, going to the field, and then back through the calibrated instrument and back to the other pole of the CT. Now is the time that I can perform the verification between the calibrated instrument and what is actually read in the field. And now I can assess if that instrument in the field needs to be changed or not. After having done this, I can restore the system in full safety. So I restore the lever in its original position. I restore the mechanical linkage between the two levers, and by pressing down the lever link, I also keep the function in its original safety condition.
Thank you, David, for presenting us this pioneering solution and the Klippon Connect TTB range for transformer wiring. It is stunning to me how many benefits are coming out of these many detailed, fantastic features. We're actually in the moment at the end of the presentation, but I'm sure you already start to consider, how can I personally or as my company benefit from all the benefits of the three phases? May they be in planning, an installation, or in operation? Then of course we invite you to contact and get in touch with our sales engineers at any time. And for now, it's left to me to say thank you for the interest in the new Klippon Connect TTB transformer wiring terminal range, and thank you for being with us today.
Thank you also very much from my side. It's been a real pleasure to deliver this presentation to you, and I'm sure we have generated the interest in this new product launch from Weidmüller. Thank you very much.
Let's connect.
Let's connect.